All right, welcome to lesson 5.1a, activity 1. We're talking about ratios. Ratios is a review from last year. It's a comparison of two things. Okay, remember we can write it in 3 different formats. We can say A to B, we can say A colon B, or we can say A over B. 3 different ways that you can write the ratio. Any of those formats is fine. In the space below, write as many ratios as you can find in the picture above. We'll just do 3. So, excuse me, I can choose any 3 things. So I got, let's see, 6 dolphins to 1, 2, 3, 4, 5 rowboats. So 6 dolphins to 5 rowboats. Okay, or let's find another one. I can do 1 lighthouse to 1 dock. Anything I want to compare in there. 1 lighthouse to 1 dock. Okay, or I could say 3 sailboats to 6 dolphins, and then that one I would have to reduce because it's not reduced. So if I say 3 sailboats to 6 dolphins, that's not reduced. So then I would want to reduce that. That is 1 sailboat for every 2 dolphins. Okay. So ratio, comparison of 2 things. Okay, activity 1. The high school has a new surf club this year. In the club, there are 14 girls and 16 boys. Use a model to help find the simplified ratio of girls to boys in the surf club. So you can do a model, or you can draw it, or you can do a chart. I like to do a chart, so I'm going to go ahead and do a chart. So in my problem, I always have to think my parts and my totals. So I have girls and boys and total. Okay, so I'm going to write what I have. In the club, there are 4 girls and 16 boys. Okay, so then I think, hey, that is a total of 20. Now, in these problems, I always want to reduce it. So 4, 16, 20, those are all divisible by 4. So that's the same thing as 1 to 4 to 5. So percents, okay? Well, if I think about percents, I can think about percents. So this is my original, my information. This is my reduced. This is my percent. I can cut, if I have 100%, what I did is I multiplied by 20. So 4 would represent 80%, and this would represent 20%. I'm multiplying everything by 20. So now I can go answer my questions. What percent of the surf club are girls? So girls, I have them at 20%. What fraction represent boys to girls? So boys as the numerator, girls the denominator. I want it reduced, so I'm going to do with my reduced ones. That's 4 to 1. What fraction represents girls to boys? That's upside down. So that we have 1 to 4. What fraction represents boys to total? So we're looking at 4 to 5. What fraction represents girls to total? So 1 to 5. Okay. Now, if we wanted to actually draw out the model, we could have. We'd have a total of 5 sections when we look at the reduced thing. 1, 2, 3, 4, 5. One of the sections has 4 girls. And the other ones, the other 4 sections have 4 boys. I drew too many sections there. 5 total sections. Okay, so that would have been my reduced model. Okay, I like doing the chart. A cat has given birth to a litter of kittens. There are 3 black kittens and 6 striped kittens. All right, so I pay attention to what I have. I have black, striped, total. Okay, I look at what they originally gave me. They said there's 3 black and 6 striped. That gives me a total of 9. I want to think of that as reduced. Reduced, those are all factors of 3. I can make that 1, 2, 3. If I wanted to draw a model, I would have 3 sections. One of the sections would have 3 black cats in it, and 2 of the sections would have 3 striped cats in it for a total of 9 kitties. What fractions are striped? We want to think of what fraction of the kittens, so total. We want striped to total. So we want to look at our reduced. That is 2, 2, 3. 2/3 of the kitties are striped. Okay, you should try number 3, pause it, try number 3, and then come back and check your work. All right, there are 16 girls and 12 boys in Mrs. Garcia's class. So I always think, okay, girls, boys total. This is not giving me very much room. Let me scoot over here so I can actually make my chart. Girls, boys, total. I write down the information I had from the problem. It gave me 16 girls and 12 boys. That's a total of 28 people. I want to reduce that. Those are all divisible by 4. So 4, 3, 7. If I wanted to find a model, I'd have 7 sections. 1, 2, 3, 4, 5, 6, 7 sections. 4 of the sections would be 4 girls. And 3 of the sections would be 4 boys. That gives me my 16 girls and 12 boys. Okay, what is the ratio of girls to students? So I want to go with my reduced one. Girls is at 4, students is at 7, so 4 to 7. And since it says ratio, we have to label 4 girls to 7 students. Now I want to go back up and make sure I did that on the other ones. If I said ratio, find fraction, 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 fraction. No, fraction you don't have to label, ratio do. So you see ratio, you got to label. What fractional portion of the students are girls? Girls are 4/7. See, the ratio I have labeled, the fraction I don't. What fraction of the students are boys? Boys are 3/7. To the nearest percent, what percent are boys? Okay, so we're using our calculator. We're going to go 3 divided by 7 and then multiply by 100. Okay, so when I write this out, I get 0.42857 to the nearest percent. That's about 42.857%. It wants to the nearest whole percent, so that's closer to 43%, so 43% about. Okay, suppose Ms. Jimenez has a huge class of 63 students in the same ratio as above. So we're stealing. We want to steal from above. We want to steal this part right here. We want to steal a reduced ratio because we know it's in the same scale, the same ratio. Has to be equivalent ratio. So girls, boys, total. Okay, so hers, when it reduces down, it still reduces to 4 to 3 to 7, except we know that there's 63 people total. So you have to think of the scale factor. 7 times 9 is 63, so multiply by 9. 36, 27. She has 27 boys and 36 girls. Okay, so we know it's proportional. So we know we still have 7 sections. It's just what's in each section is different. Okay, so we still start off with our 7 sections. That's not changing. 1, 2, 3, 4, 5, 6, 7. And we still know that 4 of the sections are going to be girls. Girls, 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 girls. And 3 of the sections are going to be boys. But I'm looking at the scale factor this time. There's 9 times as many. Okay, so each one has 9 people in the section instead of what we had above. Okay, so that represents the 36 girls and the 27 boys for a total of 63 students. What fraction of Mrs. Jimenez's class are girls? So that's still 4 out of 7. To the nearest percent, well, if 3 out of 7 was 43%, then 4 out of 7 has to be the complement, which is about 57%. Okay, what fraction are the boys? 3/7, just like above. Now we have more than just 2 things going on. We got 3 things, no big deal. Just more stuff that you have to keep track of. A package of party balloons has red, green, and purple balloons. Okay, red, green, purple. I write down the information. Yep, I forgot to write total. We always want to keep track of the total. 3 red, 6 green, 6 purple. That gives me a total of 15. Those are all divisible by 3, so I'm going to go ahead and reduce. So I don't have to draw such a big model. 1 to 2 to 2 to 5. So I know I need to do 5 total sections on my model. Okay. One of the sections is going to have 3 red balloons, and 2 of the sections are going to have 3 green balloons, and 2 of the sections are going to have 3 purple balloons. Okay, so I counted for all of my balloons. Was a simplified ratio. Okay, we did that. 1 to 2 to 2. Remember, ratio, we have to label. So 1 red, 2 green, 2 purple. Okay, all I did was take this ratio up here, 3 to 6 to 6, and reduce it all, divided all by 3. What fraction of the balloons are purple? Purple, 2/5. What percent is that? Well, we know 2/5. That's 4 out of 10, so 40%. If the ratio of red to green to purple is always the same and there's 120 balloons, how many balloons will you expect? Okay, we're just taking a new column. Easy enough. 120. So we can decide to go from 15 to 120 or from 5 to 120. Doesn't matter where you build your scale factor from. 5 to 120 is easier for me. I know that 10 times 12 would be 120. So I know I have to 5 times 2. So I'm going to have 24. Okay, so I can figure out what 120 divided by 5 is 24. So I now have to multiply by 24. So this would be a 24, this would be a 48, this would be a 48. I scaled up from the reduce ratio by a scale factor of 24. There would be 24 red, 48 green, and 48 purple balloons. Okay, that's the end of activity 1. You can go ahead and watch that video for activity 2 and then another video for activity 3. Goodbye.